For example, past time is infinite. Keeps on going backwards forever, let's say. Let's call that a hypothesis for just a second. If you could show that that hypothesis was a contradiction, and therefore you could show that that was impossible, then you could turn right around and show something else, very peculiar indeed. That the opposite of that statement, namely past time is finite, must be true in all possible universes, places, and times. Well, how would you go about doing that for a second? Well, look at that diagram just one more time. And in that diagram, just see for a second then that you can split that up right at the word is. So now, for example, let's take past time is infinite. Just take a line and draw it right through the word is. And now what we're going to do is do something that we do in fractions every day. We're going to find ourselves, as it were, a lowest common denominator. We're going to find ourselves a lowest common conceptual base. I mean, we're going to find a concept that applies to both sides of that equation, that applies to both sides of that statement, past time is infinite. Well, what could that be, for example? Well, let's take the word achieve. See, achieve does apply to both sides of that equation. So we're going to try and prove that this is a contradiction. Now watch this. Now we're going to see when we actually get to Hilbert's proof later on, we're going to see that when we use the word infinite, infinite turns out to be automatically infinity is an unachievable. You see, that's what it means to be infinite. So if you have infinity inside a series, that means it keeps on going, and it's always more than can ever be achieved. Well, what do we call more than can ever be achieved? Unachievable, not achievable. Now, if you want to say that infinity means anything else but unachievable, then you would be unable to distinguish it from finitude, from the finite. Think of that for just a moment. What is it that makes infinity to be infinity? Well, it keeps on going. If you said, no, it doesn't keep on going, what would it be? Well, it would be finite. It would have a terminus. It would stop. It would end. But this keeps on going. What distinguishes infinity from finitude is it keeps on going. It's always more than can ever be achieved. And if you want to say, no, that series is not more than can ever be achieved, you can achieve it. Automatically, it's finite. The only quality that makes it infinite is the fact that it cannot be achieved. The fact that it keeps on going. The fact that it is always more than can ever be achieved. So therefore, let's put underneath then where it says infinite, let's put unachievable. Because that's the definition of infinity. And then let's go to past time for just a second. Past time, by definition, has to have occurred. That is to say, that's the definition of past time. Past time has happened. Past time has occurred. And now let's just get one step further. It's not just that past time has occurred, but past time, if it has happened and it has occurred, it must have been achieved. It must have been done. So now we have this lowest common conceptual base. Go back to the screen for a second and just watch this. You take that word achieve and notice that when you put it under past time, it has to have occurred, it has to have happened, so therefore it has to have been achieved. But then go to the other side of the equation and look, infinity by its very nature, the only way of distinguishing it from finitude is to say that it is unachievable. It's not achievable. Now put the two statements together. Infinite past time, or past time is infinite, translates into this bizarre expression with this lowest common conceptual base. And achieved unachievable? Think of that for a second. We just achieved the unachievable. Well, if it's unachievable, then it can't be achieved. So how can you say you have achieved the unachievable? What is that? It is a contradiction. And it is no better than a square circle, a proton electron, a wave particle, or anything else which you can think of which is a contradiction. It is literally a direct contradiction. And the one thing we know about contradictions are they are impossible in any possible universe, in any possible region, in any possible time. They are impossible. They are untrue. Well, now let's just reverse it. If past time is infinite, if that statement turns out to be a contradiction, and it does, because it is an unachievable, that is a direct contradiction, then what do we automatically know? We know that statement, past time is infinite, is impossible. And if we know that statement, past time is infinite, is impossible, we also know one other thing. We know that its opposite must be true in all possible universes, places, and times. Watch this. You're proving, literally, from an analytical base, the necessity for a creation event. The necessity for time not to go backwards. You're proving, literally, that you have to have a timeless creator. A creator that is not subject to time. And this creator not subject to time has got to create only finite past time, because infinite past time is impossible for any possible universe, place, or time. And if it is impossible for any possible universe, place, and time, then its opposite, past time is finite, must be true. Past time is finite is necessarily and a priori true. And if that is the case, then you can know not only that you're going to have a beginning of past time, you're also going to have a creator of that past time, which is not in time. Now, that's a priori evidence. And now you have a real sense of what we can do here. Now you have the sense that we can actually take a priori evidence, which you and I together, we can do that equation. We can prove that contradiction together. We can see the contradiction together, just like we can. The clock is in Spitzer's hand, which is a posteriori evidence. And from that point of view, then, we can begin our proofs for the existence of God. You've got all the data that you need.